Hi, in this live video, I'm actually going to do two demos. One of them, I'm going to record the data. I'm going to do a linear sweep voltammetry on a potentiostat in front of me. Then I'm going to actually analyze the data using, in this particular case, Gemini, and turn the data, essentially, I'll do a Tafel plot analysis on the data. So bear with me. So as I say, there'll be two demos. First of all, I'll take the hardware. I'll put a screen printed electrode into the hardware. I'll put a 50 microliter drop of ferricyanide onto the what's called a screen printed electrode. I will run the potentiostat using my phone, which I'm just turning on now, and then I will actually get the data saved up into the cloud. The parameters that I'll use, I'll start at minus 200 millivolts. I'll go to 700 millivolts. I'll go quite fast because I appreciate that people sometimes do slower scan rates when doing things like kinetic analysis, Tafel plot, Butler-Volmer type analysis. But I will go fast. Why? Because I'm imagining a undergraduate demo situation. I'll put the current range at 100 microamps, and then I'll hit start measurement, and then I'll get the data. Now that data will automatically go to the cloud. So I've said what I'm going to do in the first instance. There'll be a second part to this video where I do the prompt engineering to actually analyze the data. But let me just go to an external screen here. What I'm going to do is put 50 microliters of 5 millimolar ferricyanide onto the screen printed electrode. The nice thing about this setup, especially if you're kind of in a teaching lab situation, is screen printed electrodes. It's very modern, you know, no cables, no sort of strange connections or connectors. This really inspires students, I would argue, to understand that electrochemistry can actually be very modern, especially as the second part of this demo is actually the prompt engineering part. All right, so I've put the 50 microliter drop onto there. What I'm going to do now is just label my data. So there's a couple of things I need to do. One of them is we have what's called a cluster name, so I've left that a demo. I've got ferricyanide first LSV. I'm just going to call this ferricyanide LSV Fruda. It just helps me kind of recognize it later on. Fruda. Right, and then I'm going to go continue. I will use those parameters that I mentioned earlier on, minus 200 millivolts, start potential, stop potential 700 millivolts, scan rate 100 millivolts, current range 100 microamps. I'll start the measurement. So in real time now I have current versus time, but when it goes up to the Julie system, then it will give me current versus voltage. All right, so it says upload complete. Now I'm not trying to do this demo to argue data quality. What I'm doing this demo for is actually to show a workflow and a sort of principle for a undergraduate lab. So with that said, let me just navigate slightly on my computer. I'm going to share my screen with you for a second. So when it says upload complete on the Sense It All Potentiostat, what it means is if I just put the word demo in here, this was the cluster that I saved the data into. This is my instrument. I'll do a refresh here. And I'm looking for something that says ferricyanide, LSV, linear sweep voltammetry, Fruda, and then I've got my data in here. Like I say, wasn't so interested in the data quality here. I just wanted to be interested in the workflow. So up here now, I actually have my data, and I can actually get hold of my data because I can do all sorts of analysis up here, by the way. But I'm going to go fast today. I'm just going to export my data as a CSV file. And it's coming down now. So later on, I'll be finding that data and using it in a analysis. Let me just go back to my slides to remind me. So I did the first half of my, let's say, demo today, which is the scientific experiment, let's say. Now, what I'm going to be doing next is actually uploading my data to Gemini. Now, I'm using Gemini because it seems to be the best I can find without a paywall. Now this will obviously change quite rapidly. You know that Google, ChatGPT, DeepSeek, Copilot, etc. You know their pricing all changes, but I happen to be using today Gemini because I find it's the best without a paywall in front of the features that I need. First thing I'm going to do is I'm going to give the data to Gemini. I'm going to tell it, please plot my data. plot current versus potential. The next thing I need to do is actually tell it then that I'm probably in microamps and microamps and millivolts, because you won't necessarily know my units. So I kind of correct that. I then tell it that, look, the diameter of my electrode is 3 millimeters squared. Can you turn the current into current density? And then I ask it to put it into SI units, because I'm going to be doing a Tafel plot analysis. So then I turn, so millivolts and microamps per centimeter, microamps per centimeter squared becomes amps per meter squared, and millivolts becomes volts. Then I ask it to do a Tafel plot of my data. And then I ask it to, look, I only want to analyze my data in the range potential is greater than 0 volts and less than 0.2 volts. So I'm essentially cropping the data. So I prompt Gemini to do that. Then I ask it to do a linear fit. This is probably the bit that's where one can make has the greatest opportunity to make an error, because you kind of have to say, look, I want to do a linear regression, and I told it in the region where potential is greater than 0.167 and less than 0.175. So I can understand that's probably the point where I would criticize myself the most, because you really got to get that right. But it doesn't affect the overall, this is how we grab the data. This is how we can prompt Gemini to analyze our data. Having gained the linear analysis, or sorry, the linear regression fit, you can then actually prompt Gemini to give you the Tafel slope and the exchange current density. So we can prompt it to do that. So now I'm going to do a demo of that AI prompting. So don't forget, I've just gathered the data here. I've downloaded the data from Julie, and now what I'll do is I'll just share my screen with you again for a second, which is here. So I'm sort of in to Gemini now. So now I kind of have to remember my my prompt. So I am going to give you a CSV file with a column and E, please plot. So then what I'll do is I'm going to add a file, upload files. So what I'll do now is I'm going to upload files from my downloads. So I've got some downloads here. So I will upload the file that I just... right, so let's see what it does first of all. So as I say, I've tried using, I think other AIs like ChatGPT can also do a good job on this, but it's just with ChatGPT, unless you're kind of, at least when the time I tried, unless you're paying for one of the paid versions, it quickly kind of essentially runs out of credit. So the first thing that's happened here is that it's plotted current versus potential, which is fine, and it's actually done the current on the y-axis and the potential on the x-axis. I'm going to say, please know that current, I'm going to say I is in micro amps and E is in millivolts. Please replot. What I'm impressed by with this is that once upon a time one would have had to make kind of dedicated software in order to do this analysis. Now I actually understand that what's going to happen is paywalls will go up, etc. So it's going to be a constant figuring out how to do this in the most economic manner. But with that said, whoops-a-daisy, there it was there. So now it has put the data into microamps here and millivolts here, which is great. I'm just going to check. What I want to now do is just tell it, look, the diameter of my electrode, is 3 millimeters. Please convert I into current density. Whoopsie, sorry, you can tell everything is live. Please convert current into current density. Let's have a quick look what it does there. And this is because I know in the end, when I do the Tafel analysis, I'm going to actually say, please plot current density versus potential. Hopefully, because I noticed it tried to give me as a list. And I'm very interested in hearing people's feedback so that I can actually figure out, well, not figure out, yeah, but figure out is correct, how to make sure that the AI always follows the same format. But that said, now I've got current density in micrograms per centimeter squared and potential here. So it's doing a good job there. Now what I want to do is please put all units into SI units. This will just help later on. I like this because, in fact, you know, manually you can do all of this. You know, and I get the point that obviously when you're learning and teaching, oh, there we are. It's, I'm going to now say, please replot. Now using SI units. Let's see what it does now. Oops, I've said no. So, but anyway, it's clever enough to understand what I've done. So now it's got current density amps per meter squared. The potential is in volts. Now what I want to do is please make a Tafel plot of my data. Of my data of my data. I'm just going to see if that's going to work, because what I'm trying to figure out now is that it's in the SI unit. So I'll just check back that it is actually still in the SI units. So it is having a think about it now. So it's kind of interesting sometimes because it, in this particular case, Tafel plots can be plotted either as sort of, I've seen it done, you know, the log of the current on the x-axis, which is done in this case, and the potential on the y-axis, or the other way round. So what I want to say is, please, it's just for my benefit, please plot the potential, the Tafel plot with potential on the x-axis and log of current density on the y-axis. I do like the fact that with these kind of chatbots, no, it's not a chatbot, but with these prompting, you don't always get the same thing every time, which is, you know, which is fine. I mean, I do like the price of this system. The pricing is just great. At this moment when I'm doing this, it's free. So what I want to now do is I just want to really crop my data. So I'm going to say from this point onwards, please only consider data where E is greater than 0 and E is less than 0.2. Please, I'm very polite, so I maybe please replot. So maybe the pleases are a little bit unnecessary. Let's have a quick look what it's done. So I'm now basically just trying to crop my data so that I can kind of get it to only analyze what I'm actually interested in. Now what I want to do is tell it to, let me have a quick think here, current density versus voltage. Now what I want to do is please do a linear fit. I'm going to try and do a linear fit in the region of here. This is the bit that is kind of most sensitive. So I'll just say, please do a linear regression on the data in the region 0.1675. E is that, and E is less than 0.175. Yeah, maybe just about. Okay, let's see what that does. Oh, I should have, yeah. So what it's now doing is plotting that, and then what I will say is using please or using the linear fit, using the linear fit, please calculate the Tafel Analysis region slope, and please calculate the exchange current density. Right. What I find not amazing, but it is pretty impressive that a year ago one would have had to have essentially dedicated software to do this, or one could do it, you know, in Python. One could plot it all out, do it in Excel, etc., or use something that was kind of bespoke. But in this particular case, you do not need to, you know, as you can see, I can basically prompt my way to essentially success here. So what we've got here then is the voltage per decade. So we've got the volts per decade that it's calculated, and I've also got the exchange current density, which it's put here. Now I can't comment on the quality of the data that I used coming into this, or maybe the point at which I actually tried to choose where my linear region was for then calculating my Tafel values. But, you know, that said, I think the workflow itself is super, let's say, modern. So let me just go to a quick slide here. So what I've did then is I said, look, you know, I've got this CSV file. Please plot current versus potential. Sometimes it gets it around the wrong way, at which point you have to kind of say, well, please plot current on the x-axis, and I said here, or not current, sorry, please plot potential on the x-axis and current on the y-axis if it gets it the wrong way around. So then it kind of plots it essentially the right way around. Then you have to kind of say to it, well, make sure that we're in millivolts and we're in microamps. So you can kind of prompt it to correct for that. And then you can tell it what your diameter of your electrode is, or what the area of your electrode is, so that, and ask it to put it into current density and replot, which it will do. Then what you can do is say, look, let's go into SI units. Now, when I did it this time round, it actually made a little bit of a mess up, so I had to kind of fix it a little bit, but please put all units into SI units and replot. Please make a Tafel plot of my data and replot, which it did. Then I was cropping it, so I said, look, you know, only consider the region E is greater than 0 and E is less than 0.2 volts. And then I asked it, please do a linear fit in the region E is greater than 0.167 and E is less than 0.175, which it did. And then I I then asked it, look, you know, using the linear fit, please calculate the Tafel Analysis region slope and the exchange current density, which it then gave me some values for that, which I think I was a bit concerned about my exchange current density, so I would criticize myself for that. and I think there was a little bit of a mess up when it was doing the Tafel slope, but that said, I wanted to go ahead and just essentially do this live video. So in summary, grabbing the data was actually the easiest part. So just took the sensor or potentiostat, put the screen printed electrode on that, put 5 millimolar ferricyanide on that, set it up, or rather gather the data using the parameters I ran through. The data went to Julia. I downloaded the data from Julia, and then I uploaded it to Gemini and started to prompt my way through Gemini to actually do the analysis. You have to keep a little eye on these, obviously, AI tools. So you do have to have still studied electrochemistry and done your theory on Tafel plot analysis. But then if you kind of know the background and the theory, then you can kind of ensure the quality or do quality control on the actual analysis itself. If you do have any questions or want similar videos, don't hesitate to reach out to us. Okay, thanks very much.